Good morning, everyone. Long time since you probably heard my voice, but just wanted to make a video, try and change things up a bit, and see how all of you guys are doing. First things first, I just want to make sure that I show you guys this. This is the Google Classroom. I only have about 6 of you guys on here, and I haven't heard from many of you in a long time. So if after you, actually the first thing I would like you guys to do is if you could go, I'll send you guys an email, but if you guys can go into Google Classroom, you're going to take this code here, which I will also copy into the email, and you're going to join the Google Classroom. Because a lot of what I want to do today might involve Google Classroom. But I just want to say that first because I also want to be able to share big videos with you guys in Google Classroom. But for today's work, there's a few things I wanted to show you. The first one, what I wanted to do is I wanted to talk about this assignment I assigned before Easter break. One of the things I asked you guys to do was to build an atom using this PhET, P-H-E-T simulator. And I've only gotten a few responses, so I figured I'd show you guys what I was looking for. So when you click that link, it'll bring you to this page here. And what you'll do is you'll click into where it says atom, click into that, and it'll bring this screen up. And I know you guys haven't seen a lot of this. We haven't really talked about a periodic table, mass number, net charge, and all that stuff. But that's okay. I just wanted you guys to play with this, see what you could figure out, what you couldn't figure out, and then we talk about it from there. But so what you see here, these three components down here, you have protons, you have neutrons, and you have electrons. These three things are the main components of what we call an atom. When we talk about an atom, it's the smallest building block of any matter, right? And what we can do with these is we can play around with them. We can put the protons and neutrons in what we call the nucleus here. The very center of an atom is the nucleus. And what we can do is we can put as many protons and neutrons as we like in the middle here. So I can keep putting protons and neutrons here. But notice it has this plus ion up here. We haven't talked about the word ion yet, but that's okay. Plus ion, an ion means it has an uneven amount of electrons and protons. So there's an uneven, or there's not the same amount of electrons as there are protons. Because right now I have 2, right? The red ones are the protons, and we have 0 electrons. So if I were to put 2 electrons into here, it says neutral atom, because now there's 2 electrons and 2 protons. The neutrons are a little funny. Let's see if I take one away. It still says it's neutral, right? Because neutrons actually have a neutral charge. What I mean by that is protons, think P proton, have a positive charge. That's the big takeaway from this. And so what I really wanted you guys to do in this assignment was to come up with as many many different kinds of atoms as you could, or I think the minimum was 3. And so right now, as you can see, if you look at the periodic table of elements over here, is that I have made the element helium. Helium has 2 protons, 2 electrons, and 2 neutrons for it to be a neutral atom. Now, if I were to keep throwing these in here, so protons, add maybe 3 more in, see how this word up here changes every time? So the atom usually depends on how many protons there are in the atom. So I'm just evening that out. So now I've made carbon, because carbon has 1, 2, 3, 4, 5, 6 protons. If I were to throw in a 7th one, it'd go up 1. It would go up 1 from carbon over here. It's going to go to this N, which is nitrogen, because nitrogen has 8 protons. I'm just going to keep this balanced with these neutrons. And then I'm going to throw in a bunch more electrons, because remember, to get rid of this positive ion charge over here, it needs to be equal amounts on either side. There we go. So now I have 8 total electrons. Now you see how there's 2 in this first, what we call these orbitals, 2 electrons in the first orbital, and then how many are there in the outer one right now? 1, 2, 3, 4, 5. You can have a total of 8 electrons in the outer orbital. but we're not going to worry about that right now. So this is what I was kind of looking for when I asked you guys to make an atom. So what you would have done is you take a screenshot of this and send that to me. So that's all I wanted to talk about for this simulation. I hope that makes things a bit clearer. But now what I want to do is this is kind of my lesson plan for what I want to talk about in this video. So right now I've explained how the PhET simulation should work. Now what I want to do is talk about the PowerPoint that I sent out before Easter break, which is here. Don't worry about that quite yet. We'll talk about that at the end of the video. So elements, compounds, and mixtures, right? Get my laser pointer out here. Ooh. The big thing I want to take away from here, so this is some of the learning outcomes for today, to define an element, compound, and mixture. So some of you are already able to do this, so you can skip through this part of the video. But those of you who are still confused about elements, compound, and mixtures, I want you guys to really pay attention here. So elements. Elements are things that we're going to find on the periodic table of elements. So you guys have heard of gold, right? Well, gold is something we can find on the periodic table of elements, meaning that it is only one thing. It is made up of only one element. Like we know oxygen is on the periodic table of elements. All of the molecules within this band of gold, you see this ring of gold over here, are all gold. Same with these charcoal sticks over here. All of these are made up of one element. That element is carbon, because we find both of these things on the periodic table. Compounds, on the other hand, are made from two or more elements which chemically react together to form new substances. So if you were to go back here and we were somehow to take gold, which we know is an element, right, and carbon and put them together, that would form a compound. Like this graphic over here, like this graphic over here, we take hydrogen and we take oxygen, which again are both on the periodic table of elements. If you combine them somehow, you make water, which we know is H2O, or it has two hydrogens and one oxygen, and it looks like this. You see there's two molecules out here and one in the middle. So this is a compound when you take multiple elements and put them together, right? Compounds are made from two or more elements. Lastly, we have mixtures. These are the easiest ones to understand because I think you'll see them every day. But a chemical mixture contains elements or compounds that are not chemically bonded together. So you see in this graphic over here, you have these are going to be H2O molecules because we see the little tiny ones on one side and the big one on the other. Then we see this big purple molecule, and then we see this big red one. They're all kind of mixed together into this picture without being bonded together. We can tell that the water molecules are bonded together because they're actually sticking to one another. This is just kind of a quick graphic to overview this. You guys have access to this PowerPoint, so I won't stick around too long on it. But just as a real quick recap on what these are. So we have rocks, all these different kinds of rocks, not the rocks themselves, but the rocks just kind of sitting together, right? Like this picture of rocks, are these rocks elements? Are they compounds? Or are they mixtures? They're going to be mixtures. You have a bunch of different rocks all mixed together. Copper, on the other hand, what do you guys think copper would be? Copper is going to be an element because we can find it on the periodic table. If we were to go back to that PhET simulation, or if I'm going to just pull up a periodic table of elements, periodic table, you would be able to click on any one of these. I'm just going to click on the first one I see. It's actually the Wikipedia one. And you can see really tiny there, number 29 is Cu, is copper. So that's how we know it is an element. And then jelly beans, all these different kinds of jelly beans, the red with the black and the purple. Again, that's just going to be a mixture. They're not chemically bonded together, and we know that jelly beans aren't an element because you can't find them on the periodic table. You're not going to find JB jelly beans on the periodic table. Table sugar, on the other hand, is not an element because you can't find it on the periodic table. You might think it's a mixture, but actually it's a bunch of chemically bonded elements. Table sugar, this over here, bring my laser pointer back. C12H22O11 is the chemical formula for table sugar. It's just its common name. So if you take 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen and chemically bond them together, you force them together, kind of like in this picture way back here. If you take all those atoms and stick them together without them floating around away from each other, kind of like they are here, you will get table sugar, making it a compound. Remember, compounds are atoms that have been chemically bonded together. So you can take a look at the rest of this PowerPoint. Diamonds are actually all one element, made up of one element, which is carbon. So that makes this an element because it's all one. Just because you can't find diamond, the word diamond on the periodic table doesn't mean what it's made up of. It's one continuous thing called carbon. Tea is a mixture because you're just taking what's the tea leaves in the tea bag, mixing it with water. I can go through this the rest of the day, but I really want to move on to the last thing, two last things here. We've been talking about this stuff for a long time. So what I want you guys to do between compounds, elements, and mixtures and an atom is send me, whether it's a Word document, you share a Google Doc with me, whatever you find easiest, 3 things you've learned about compounds, elements, and mixtures, or atoms. 2 things you might have already known about compounds, elements, and mixtures. And 1 thing you'd like to know, 1 thing you're still kind of confused about, or just a general question about things, you're curious, let me know. So 3, 2, 1. Let me know what you think. Okay? And lastly, so we did a short revision of elements, compound, and mixtures. We did a 3, 2, 1 of understanding. So lastly, this is going to be really easy. Don't overthink it. This is finally finding or modeling any of the 3 elements, compounds, or mixtures. So you can make this however you want. But what I want you guys to do is either find a mixture or a compound or an element in your house. Like I have coffee sitting next to me here, banging on the table, that's my cup of coffee there. That would be a mixture, right? Because I'm taking the coffee beans, grinding them up, and running water through those coffee beans. But there's also, I'm doing this work on a glass table, and this glass is a mixture of sand and other things, and that's a compound, right? So what I want you guys to do is, or maybe if you have some Play-Doh or whatever lying around the house, you can model a compound for me. Kind of like if I go back to my PowerPoint here, I go way up to, where to go? It's really easy. If we were in school, we have these model building kits to make one of these oxygen or water molecules by just taking making the little red balls and then little green balls and kind of stick them together, and you can model for me H2O. So however you like, but what I want you to do is you can either send me a picture of what you find and tell me whether it's an element, a compound, or a mixture. Okay? I believe that's all I have for you guys. What I want you guys to do is those few things, and let me know how this video helped. If I'm talking too fast, if you like it, if you don't like it, it's just something I wanted to try this week. And remember, I will remind you guys one more time, sign up for the Google Classroom, please. I've invited most of you. All you have to do is accept the invite. But join this Google Classroom. It makes things so much easier for all of us. And I will talk to you guys soon. Thanks.